Welcome to this explainer. Have you ever actually stopped to think about the split-second magic that happens when you just glance at your phone and it opens, or when you press your thumb against a glass screen and boom, you instantly have access to your bank account? Well, today, we're demystifying that exact moment. We're going to take a really fascinating journey inside the machine to understand exactly how a device recognizes you.
Okay, let's dive right into this. Essentially, your face is your password now. Your fingerprint unlocks your bank. Your voice can actually verify your identity with a customer service agent. Our biological features have quite literally become the keys to our digital lives, completely replacing those old typed-out codes. But how does this all actually work behind the screen? And probably more importantly, can this technology be fooled?
So, just to make sure we're on the same page, we first need to define what we're actually talking about here. Biometrics are simply your biological characteristics being used as unique identifiers. The massive shift in the security world is that we are moving away from something you know, like a PIN or a password, or something you have, like a physical keycard. Instead, we're authenticating based purely on something you are. It is a fundamental, ground-up change in how we prove our identity. Here is our agenda for this explainer. 1. You are the password. 2. Fingerprints, faces, and voices. 3. The secure enclave vault. 4. Security versus convenience. And 5. Fooling the machine. All right, section 1. You are the password. From memory to biology. For absolutely decades, we relied heavily on passwords, right? Something you know. But let's be honest, the problem is they're incredibly easy to forget, we reuse them way too often, and they get stolen in data breaches constantly. Biometrics, on the other hand, represent something you are. They're uniquely yours, and honestly, the best part is you literally never leave them at home. Think about the last time you breezed through an airport passport e-gate. You didn't type a code, you just presented your face. Everyday actions are now entirely reliant on this biological security because it completely bypasses the fundamental flaws of human memory. Moving on to section 2, fingerprints, faces, and voices, translating biology into mathematics. Now, what's really interesting about this whole process is a core concept you have to keep in mind. Your devices absolutely do not store pictures of you. They store mathematical translations. During a simple laptop fingerprint login, this completely invisible, multi-step process happens in milliseconds. When you press your finger down, step 1 triggers. The sensor captures an image of your print. But it doesn't just save that picture to a folder. In step 2, the software goes to work, analyzing the image to extract what are called minutia points. These are the highly specific, unique details of your print, like where a ridge ends or where it splits into two, which is known as a bifurcation. Finally, in step 3, those very specific points are translated into a mathematical template. And that math equation, that's what actually gets stored and compared the next time you touch the sensor. And facial recognition follows a very similar translation principle, but the technology there has evolved dramatically. Basic 2D facial recognition simply maps the flat geometry of your face from a standard photograph. The glaring issue there is that 2D geometry is relatively easy to spoof. Sometimes someone simply holding up a high-quality printed photo of you can trick it. No way, right? That is exactly why modern, highly secure facial recognition creates a 3D infrared depth map instead. It maps the actual physical contours of your face in 3 dimensions, making it vastly harder to fool. So just how detailed is that 3D depth map? 30,000. That is an unbelievable number. Systems like Apple's Face ID project 30,000 invisible infrared dots onto your face in literally a fraction of a second. It reads the specific distortion of those dots over the shape of your nose, your cheekbones, your jawline, and uses that to create a highly detailed 3D topographical map. And again, to be super clear, it doesn't save a photograph of your face. It saves this map as a deeply encrypted mathematical model. But hey, it's not just physical touch and sight, it's also sound. Voice recognition is being used more and more, especially in those bank voice verification calls. To recognize you, the system analyzes a bunch of different factors: your pitch, the cadence or rhythm of how you speak, your formants, which are basically the acoustic resonances of your voice, and even the physical biological shape of your vocal tract. It actually turns out your vocal tract is as unique as your thumbprint. All of these metrics are analyzed together to create a unique voice print. It's essentially the mathematical fingerprint of your vocal cords. Okay, section 3, the secure enclave vault, where your biological math lives. So, the crucial point is, with all this highly sensitive mathematical data representing your actual body, where does it all go? Enter the Secure Enclave. This is a separate, physically isolated chip inside your device. Its one and only job is to store your biometric templates securely. When you use your face to unlock a banking app, the app doesn't actually see your face. Even the phone's main operating system doesn't see it. The phone simply asks the Secure Enclave, hey, does this face match the math? And the Enclave just sends back a simple yes or no. Your biometric data never, ever leaves that vault. This isolated vault system is a perfect example of on-device processing. Keeping those templates stored locally on the hardware is incredibly secure. The alternative would be cloud processing, where your biometric data gets transmitted over the internet to centralized servers for verification. And obviously, sending highly sensitive data over the web naturally introduces a much higher risk of interception or massive server breaches. So keeping the math locked safely on your physical device is pretty much the gold standard for consumer privacy. And there is a very good reason the tech industry and lawmakers treat this data with such extreme caution. Under the EU's General Data Protection Regulation, or GDPR, biometric data isn't just considered regular personal data. It is officially classified as special category sensitive data. That comes with incredibly strict legal protections. And why is that? Well, think about it. If your password gets compromised in a data breach, it's a hassle, but you just change your password. If the mathematical template of your face gets stolen, it can't exactly change your face. The sheer permanence of our biology makes protecting this data absolutely critical. That brings us to Section 4, Security versus Convenience, Walking the Tightrope. And this brilliantly illustrates a built-in tension in literally every biometric system on Earth. Engineers have to perfectly balance two opposing forces, the false accept rate versus the false reject rate. The false accept rate is the security side. How often does the system accidentally let an imposter in? The false reject rate is the convenience side. How often does the system accidentally lock the real user out? If you try to make the system so incredibly strict that it never ever lets an imposter in, it might suddenly reject you just because you're wearing sunglasses or a hat, or if your finger is slightly wet. That is highly secure, sure, but it's terrible for everyday convenience. Finding that perfect sweet spot is the ultimate engineering challenge. To really wrap your head around the massive difference in security scale here, just compare these two methods. The false accept rate for a standard fingerprint sensor is roughly 1 in 50,000. That's pretty good. But then compare that to Apple's Face ID, which uses that 3D infrared depth map we talked about. Its false accept rate is 1 in 1 million. The sheer mathematical detail captured by those 30,000 invisible dots makes it exponentially harder for a random person to unlock your phone compared to a traditional fingerprint. Finally, Section 5, Fooling the Machine, the cat and mouse game of biometric spoofing. Because look, just because something is harder to spoof absolutely does not mean it's impossible. It's a constant, invisible cat and mouse game. These systems are constantly being tested by vulnerabilities. For facial recognition, identical twins pose an obvious biological challenge right out of the gate. But there are also everyday hurdles like facial injuries, or even just the natural process of aging, which slowly alters your biometric math over time. And then, of course, there are the active malicious threats. We're talking spoofing attacks using high-end 3D printed masks and increasingly AI deepfakes. AI-generated video and audio can be so incredibly realistic today that they can actually fool some facial and voice recognition systems. It is a genuine, rapidly evolving threat. Let's move to and see how this builds into the industry's primary weapon against all these evolving threats, which is called liveness detection. Modern biometric systems don't just passively ask, does this match the math? They actively ask, is this thing alive in front of me? They check for dynamic signs of life. The sensor might look for the micro movements of your eye blinking, the natural, subtle movement of your head, or as we discussed, true 3D depth. This allows it to instantly reject a flat photograph or an AI video playing on a screen. Liveness detection is ultimately what stops a thief from just pulling a picture of you off social media and using it to drain your bank account. So this entire invisible war of complex mathematics, secure enclaves, and liveness detection happens instantly, all around us, every single day. Every time you make a bank voice verification call, every time you walk smoothly through an airport passport e-gate, or use features like MasterCard's Selfie Pay to approve a quick transaction, you are relying on this delicate balance of engineering. It's truly a marvel of modern technology working tirelessly in the background of our everyday lives. Which really leaves us with one provocative question to ponder. Is your body the ultimate security system? As this technology continues to evolve to read our biology with ever-increasing precision, the line between who we are and how we access our digital world is completely disappearing. Thank you so much for joining me for this explainer. If you found this fascinating and want to keep decoding the invisible tech that is shaping our lives, hit that subscribe button, and I will see you in the next one.